I have sat down and looked over the rest of this chapter on this is chapter 11, B cell generation, and I've come to the conclusion that there's not a lot in here that you'll have to memorize. I know that'll come as a disappointment to you, but I really would like to kind of breeze through some of these chapters so that we can get to the chapters that are more pertinent to a majority of you. Many of the students taking this online class are taking it out of desperation for needing to get into pharmacy school or wanting to get out and go on with their own lives. So let's move through this fairly quickly. I'm going to page through the rest of the chapter and talk about the important things that you need to concentrate on. And then in the next chapter, we can move on pretty quickly. I don't expect you to memorize all of the signal transduction pathways that occur in here. I would just read through and kind of get a gist of what's going on. I might ask a discussion question on the third test, but I doubt it. That you just have to understand that there are cell surface molecules that if they're present, they will signal or they'll serve to bind to certain signal transducers. And that's kind of helping to control the regulation. You have negative selection, which is like clonal deletion that can delete them. You have editing that can occur. So if a B cell is coming through and oops, it's not going to work, sometimes they can stop and they'll edit the light chains on the receptors and put a new light chain in its place in order to try to salvage all the work that they've put into it. You get the table built and it's got one bad leg. Maybe we can replace that one bad leg and make it work. Alright, that's on page 278. They're talking about self-reactive B cells may be rescued by editing of the light chain. Glance over that. Let's see. And I mean, I like this stuff, and still reading through some of the signal transduction pathways puts me to sleep. So I know it's got to be awful for you. So I would just breeze through this and kind of get the gist of what's going on until we get to T helper cells play essential roles in most B cell responses. That's on page 285. And look at that sequence of events in B cell activation. That's in that figure. It's figure 11-12. You want to read that one section a little more carefully than the rest of this. I think Goodenough's experiment is interesting, but I'm not going to have time to really ask a lot of questions on that. It's kind of funny because you're talking about hen egg white lysozyme or HALE, and then antibodies that are anti-HALE, and it's an interesting experiment, but it won't be tested on. There's just no time to test you on all of this stuff. Let's see. Figure 11-16 is interesting, and it's talking about differences in the concentration of different serum antibodies following primary and secondary immune responses. So you can really carefully go over that figure 11-16. It will help you out. If you are going into pharmacy, you may want to read the T helper cells play a critical role in the humoral response to haptene carrier conjugates. That's on page 290. Just try to keep in mind that every person's different. Their immune systems are different. So when you're prescribing drugs, any drugs you prescribe could possibly, or well, not prescribe. If you're a pharmacist, you're filling the prescription. But any drug that a person takes can initiate allergic responses by serving as hapten carriers. So the fewer drugs and the lower the doses of the drugs that you give, I think is a better situation. But look at that hapten carrier conjugate section. Affinity maturation. This is on page 293. It's where that starts. Affinity maturation and the role of somatic hypermutation is going to be an extremely important section. I mean, if you're going to read nothing else in this chapter, read through those few pages. Let's see, that starts at page 293 and ends on page 296. Please read through those. Class switching, what's the role of selection, all of that is pretty good stuff. I don't think it requires me to sit here and read it to you, though. The section on the presence of an antibody can suppress the response to an antigen is just doggone it's interesting. And since antibodies are technically a biochemical reaction, they are proteins that can bind, they can have feedback inhibition on their own production. So if you start getting a large amount of an antibody, then it can suppress, by blocking all of the antigens, then it suppresses the B cells that are flowing through the bloodstream. Does that make sense? So if you have too many antibodies, you're going to block the antigens before the antigens can bind to memory cells. So you're not going to get any future affinity maturation processes occurring. So actually having a cell that produces too many antibodies can interrupt the immune system from being able to evolve for future exposure to the same antigen. Alright, so that's rushed through that chapter, but there really isn't that much for you to study. We'll move on to chapter 12 next.